Hello students, in the first lecture of singular and double point, we have defined the different terms. We have defined singular point, the multiple point, double point, node, cusp and convergent points. Now in this chapter, we'll discuss how to find the nature of origin as a double point. How to find the nature of origin as a double point. So the first method is find the equation of find the tangents at the origin by equating to 0 if the curve passes through the origin. 0 the lowest degree terms in x and y of the equation of the curve. To find the equation of tangents at the origin, put the lowest degree terms of x and y. Lowest in x and y is equal to 0, and if that will give us the two equations, then we can discuss for the double point for cusp node or convergent point. If that will give us the only single tangent equation, so we can't discuss that for the we can't discuss the double point. If the origin is a double point, then we shall get two tangents which may be real or imaginary. If the point is the point at which if the origin is a double point, then we'll get two equation tangents, whether both are real or imaginary, real, coincident, or imaginary. The second step is if the two tangents are imaginary, then the origin is a conjugate point. If the tangents at the double point origin are imaginary, then origin is a conjugate point. If the two tangents at the origin are real and constant, then the origin is a cusp or conjugate point. If two tangents at the origin are real distinct, then the origin is a node or conjugate point. Now, double point, we want to decide whether double point is a node or now if it is if the conjugates are two tangents are imaginary, then we have come to the conclusion that double point is a conjugate point. But if the tangents are real, real and distinct or real and coincident, then we have a conclusion about the double point. So for that, we have to discuss it for we have to discuss the double point further. Double point is node. Whether double point is node or a cusp, we have to we have to examine the curve. If the tangents will not decide the nature of the point, then we have to discuss at the double point the uh, curve, which the curve is passing through. We have to examine the curve in the neighborhood of origin. Examine the curve neighborhood point. If the because tangent at the point creates confusion, so we have to examine the curve in the neighborhood of the origin. If the curve has real branches through the origin, then origin is a node or cusp. Otherwise, it is a confusion point. So this is the important. We have to discuss this. How to decide, how to discuss this. We will discuss it later on. Test of nature of curve in the neighborhood of origin. How to discuss it in the neighborhood of origin. Suppose if the tangents at the origin are given by y square is equal to 0. If the tangents at the origin are given by y is equal to 0, then solve the equation of the curve for y. Solve the equation for y, neglecting all terms of y containing power above. Solve it for y. If you are solving, if the two tangent are given by y square is equal to 0, then you solve the equation for y. Y by neglecting the deleting the terms of y whose power are greater than 2. If they exist in the equation of the curve f of x. If the value of y for small value of x in the neighborhood of origin are found to be real, then branches the branches of the curve through the double point are real. Otherwise, real. Now this will decide everything. If the value of y for small value of x in the neighborhood of origin are found to be real, then the branches of curve through the double point are real. Otherwise, nil. Similarly, we can discuss if the tangents at the origin are of the form y is given by x equals 0. Then what we'll do? Then we'll solve the equation for in terms of x by neglecting the terms of x whose power are greater than 2 from the equation of f equals 0, and then solve it for x. Similarly, if the value of x is real in the neighborhood of the origin for small values of y, then what will happen? Then the real branch of the curve passes. If the real branch of the curve passes, passes, then then the then the point is a then the double point. Then the double point is a node or cusp. Otherwise, if if the value of x is real, then then the two branches pass. Otherwise, if the value of x is imaginary, otherwise imaginary. After solving it for x, if the two when the two branches of the pass through the double point are real, if the small value of x, small value of y, x is real, then two branches of the pass through the origin. Otherwise, two real branches pass. Otherwise, imaginary. Right now, second method we'll discuss it while solving problem again. Second method to find the nature of the double point. First step is we differentiate f of xy, just polynomial f in xy is to x, then y, then second derivative is to x, f is to x, second derivative of f is to y, f is to x and y. We'll find these five terms. Now from the we create first two positive f is to x equals 0, positive y f is to y 0. We'll solve these equation for x and y. Get the positive double points. Reject possible points, double points which do not satisfy the rational derivative of f is equal to 0. Out of these possible double points, we will reject those double points which will not satisfy the equation, the rational derivative, right? And the remaining points are the double points. Now to discuss the remaining double points, at each of the double point, we find the value of d is equal to positive f is to x, y, second derivative is to x and y, whole square minus positive f, second positive is to x and second positive y. The product will find the value at those double points. Find the d at the possible at the double points. If they comes out to be number one, then they will decide it. If the d comes out positive at the double point, then double point is either node or conjugate point. If d comes out positive at the double point, then the double point may be either node or conjugate point. If that comes out to be 0, then we say if the d is equal to 0, the double point is a cusp or node. In case of AB, find the nature by shifting the origin to the double point, then test the nature of the tangent and axis of the curve in the neighborhood viewpoint. Because we are not clear whether the point is the double point is a conjugate. They give this gives us two conclusions. When you calculate d at double point, this gives us confusion. Confusion it gives either node or conjugate point. Now now we have to decide whether it's a node or conjugate point. If it cusp or no conjugate point, then what to do? Find the nature by shifting the origin to the double. Now we have to shift the origin of the given equation to the double point. Then test the nature of the tangent and axis of the curve in the neighborhood. That will decide whether there is node or conjugate point, cusp of it. But if d comes out to be less than 0 negative, that point is conjugate point. Straight away, if d comes to 0, less than 0, then it's a conjugate point. Now let us discuss over everything with help of a question. Whatever we have studied, we'll discuss in the problem. Examine the nature and position of the point on the curve x of 4 y square is equal to x of 4 into 2x square minus 3x square. Now, general method. Equation of the given curve is this. Now we'll connect it to f of xy. Shift the terms to the one side, either this side or that side, to 0. Now, differentiate f. Find the first step. Differentiate to x, f of xy, then y, then put them equal to 0. First step is put them equal to 0. Then solve these equations. Solve these two equations for x and y. X and y. From x, this we got x is equal to plus minus a and 0. And from this, we got y equal to 0. So the possible points are, we got 3 value of y, 1 value of y, and 3 values of x. So take their order here. 0, 0, 0, a, minus a, 0, a, 0. Order here. X, y, x, y, x, y. So the possible double points, these are what the points we got after solving partial f is to x and partial to y is to including after 0, we got the possible double points. Now, if these points satisfy the equation resistant algebraic curve, then they are double points. Now put their value in f of xy, and if they'll satisfy it, suppose we were substituted f x by x by a minus a and y will 0, we solved it, but they come to minus a, which can't be 0. So minus a and 0 does not satisfy the equation resistant curve, so this point will not be a double point. Now similarly, at the point at the point at point a0, put x equal to a, y equal to 0. Again, this is minus a, which can't be 0. So these 2 points are not double points. Put a 0, 0 again, third point, this comes to 0. So 0, 0 is the double point. Now this point can be discussed for conjugate point. Double point, for any point to be cusp node or conjugate point, it must be a double point. So now we'll discuss it further, whether this is a cusp, this point is a cusp, or a node, or a conjugate. Now for this, we'll find second derivative of f is to x, second derivative of f is to y, and second derivative of f is to x, or x and y, or with x with x first x then y, then value x, first y then x, first x then y. Both will be conserved, and you can check in each problem. Okay? So and find the value at the 0, 0, and put find the value 0, 0. X is 0, put x is 0 in the right hand side of this equation, 0, 0, 0, 0, 0, 0. So this comes to 0, 0, and this comes to 0. And find d, second derivative of f which to xy whole square minus second derivative to x into second derivative to y of f. Put their values, and this comes to 0. If this is 0, now we go to theory, then origin will be either cusp or conjugate point. Now to decide whether it is a cusp or conjugate point, whether it is a cusp or conjugate point. So up to this, we can discuss in some other way also. This problem we have discussed about this. Now we can discuss in some other way, because this equation passes through the origin. This equation passes through the origin. So now equate to 0 the next method. Equating to 0 the lowest g term uh, in x and y. Lowest g term of x y is equal to 0. So lowest g term is how much here? Lowest g term is equal to y raised to power y square. Is a constant. That's 4, that's 6, and lowest is this. So lowest is y square. Put y square is equal to minus a is of 4, y square is 0. This will be 0, implies y square is 0. Tangents are real and constant, which verifies that origin is either a plus or no. Same thing. If you decided by doing this much calculation, same conclusion we can draw from that. Afterwards, the same discussion for both. for this also as well as this also. Now our aim is to decide whether this is a cusp or a conjugate point. Now the equation telling is y square is equal to. Now neglecting all terms of y containing power above 2. Equation first, from equation first, solve it for y. Now this equation, this curve does not contain power of y more than 2. Therefore, straightway now solve it for y. Put this to 0 and solve it for, put f of 0 and solve it for y. After solving for y, we got this type of function. Solve it for y is a function of x. Now this factor will decide whether in the neighborhood of origin. Now for small values of x is very small number. Now discussion for this is, so for this is for small value of x, positive or negative, in the neighborhood of 0. Small value of x means, so origin very small, close to this, very close to this, very small number. If x is small, the x square will still smaller. So this very small number as compared to the fixed number. So this become negative whether you take to x positive from the left neighborhood or from right neighborhood of origin. This comes out to be negative, right? In every problem you have to discuss this thing. X very small means x is 0.0001 whole square becomes still smaller into 2 smaller compare as compared to this. So this term will be negative. And negative is complex. So in the neighborhood of whether for small value x, positive or negative, in the left or right neighborhood of 0, the term under the root, this is negative, right? How is negative? Negative, this negative is this very small, and this very small is compared to this, so this term will be negative. And so y is imaginary in the left and right neighborhood of x root 0. Hence, no portion of the curve lies in the neighborhood of origin. So now it's not a cusp. If the values of this comes out to be real, then the point would have been a cusp. Otherwise, it is a origin is a conflict point. Thank you very much.